Let's play Is It a Function? In this video, we're going to learn what a function is and what it isn't and how to determine that. And let's begin by looking at our friend, the Coke machine or pop machine. If you are from Buffalo, New York, you would say it like that if you're like me. And we have talked about this a lot, and we talked about the inputs and the outputs. And when we look at the machine here, remember, what are the inputs? What are the outputs? What do you do to get for an input? What do you get out of it? Well, out of the machine, we get a bottle of Coke, right? Down here, we get our bottle of Coke, whatever that looks like, and our button is here. So the buttons are our inputs, and there are 8 buttons. So we have 8 buttons, B1, B2, B3, B4, B5, B6, B7, and B8. That's our domain. Our domain and our range are the different items that we could possibly have. So we have Coke, and we have Coke Zero, just gross stuff, Coke Zero. Then we have Diet Coke, we have Cherry Coke, we have Sprite, and we have water. Why you'd pay for water? Not really sure. But we have water. All right, and then each of these inputs, each of these buttons map to a certain output. And it's a function because each input has only one output associated with it. So if you push button 1, you expect to get a Coke. If you push button 2, you would also expect to get a Coke. And if you got something else, it would not be functioning correctly. Button number 3, you expect a Coke Zero. Button number 4, you expect a Diet Coke, and so on. We can do the rest of this. Button 5, Cherry Coke. Button 6, a Sprite. And then button 7 and 8, both we would expect a water. And there are different ways that we can represent this. We can also, let's try it this way. Let's say that this is our domain right here, and we have B1, B2, B3, B4, and so on. And this is a way to also think about domain and range. And then if we took all of our, we'll just call it Coke, we'll call it Coke Zero, Diet Coke, Cherry Coke, Sprite, and water. A way of thinking about how we map a function. Oh, and sorry, that is our range right here. This is our range in this circle. So you can think about it as 2 distinct sets. Our domains are all over here. They each map to a range. They all have a specific output. So again, button 1 will give us a Coke. Button 2, and notice the arrow is going this way because the inputs lead to an output. Button 3 gives us a Coke Zero. Button 4 gives us the Diet Coke. Button 5 gives us a Cherry Coke. Button 6, a Sprite. And then button 7 and 8 both gives us water. And you notice that each input is only going to one output. From the domain, there are 8 elements of the domain, and there are 8 arrows going out. And so this is a function where each input only has one output. Well, let's look at some more with just the numbers and see if we can determine if they're a function or not. So the question is it a function? Let's look at the first one right here. This is number 1. Is this a function? Well, let's see. We have 2 input 2. You put 2 into the function, you get 4 out. You put 3, you get 8, 4, 8, 5, 5. So for every input, there is just one output, or each input only goes to one output. So this would be like, hey, we push button 2 and we get a Cherry Coke. We push button 3, we get a Coke. We push button 4 and that also gives us a Coke. Button 5 gives us a cherry Dr. Pibb or something like that, a Mountain Dew. So that one is a function. So yes, we have a function. Now let's look at this one. Okay, button 4, the input of this function, function number 2, gives us 7. 5 gives us 2, but look, 5 could give us 2 or 9. That would be like pushing the Coke button and you by accident get Diet Dr. Pepper. I mean, who wants that? So this is not a function. Not a function. Sorry. Even though 8 and 4 do map, 5 does not function correctly. For that input, there are 2 outputs, and that does not function right. Now, how about this one? Color to hair to people to color of their shirts. So, dude number 5, we want to know what color shirt he's wearing. And they're just solid colors. Well, look, it maps to either red or white. That doesn't help us. person number 2 is wearing a black shirt, person number 1 a green shirt. So these two map, but number 5, it could go to either one. See the range, the output over here. There are 2 values for this input, and so that is not a function. So this is not. So I hope we're getting an idea of what is a function and what isn't a function based on how it maps. Well, let's look at this last one down here. This is a special case, and you can clearly see it's a function. For every input, there's an output. And we call this for where each input has its very own output, distinct. They don't share any outputs. It's not like at number 1, you push that button, and number 2, and they both give you a Coke. Each button just gives you one unique output, and we call this one-to-one, a one-to-one function right here. So know what that means when there is a unique output for every input. So what makes a function a function? What makes a function here? Well, it's when there is one for each input. Whoops, sorry about that. Each input has one output. Each input has one output. Great. Well, let's look at another example of what this could look like. Graphs. We haven't talked much about graphs being functions yet, but we've just gotten into this with our function notation. So if we look at this is a vertical line, or the pink line is has a slope, some slope. We could count it, we could figure it out, but we're not too worried about it right now. What we're worried about is this a function or not? And one thing we can use is the vertical line test to tell. And why is that? Well, let's look at certain x values. Here's an x value for, or let's pick this one right here. So this is x equals 6. So if x is our inputs and I say what's our output, well that would be our y value. So our y value is 5. All right, so this is a point 6, 5. And that is an input, and that's its output, its unique output. And you can see that for every x value, so if we picked another one like down here, this is -5 in the x, and this is around 1, 2, 3, 4, -4 in the y. There's only one output, only one y value. And so therefore, this is a function. And the way we can tell is using the vertical line test. So if I take this line, this vertical line, and I drag it over, if I can grab it, there we go. If I drag it over, notice that when this vertical line, remember this is at a line of x equals, so right now it's at x equals 0, right now it would be x equals 1, and so when I drag this across the function, it will touch only one piece of the graph, which means it maps to only one y value. So for every x value, there is only one y value. Let me show you an example of what isn't a function. So let me draw something like this. Let me draw this curve. All right, now think about it. Is this a function? Why or why not? Well, let's use the vertical line test. Let's use our line, our green line right here. Let's drag it over. Now let's see. Now right here, I've got to bring it to the front. I got the spinny beach ball. Well, as you can see, let's see, bring to front. It's not letting me bring it to the front. Well, sorry about that. Let me send this one to the back. Maybe I can do that. Nope, it won't let me do that. Oh, there it is. Send to the back. Sorry about that, guys. Okay, so here's my green line. And if I move it over the graph, you can see that. So say here is that x equals 1. Well, look, where x equals 1, it hits the graph in 2 places. So if your input was 1, if your input was x equals 1, well, the graph would give you 2 things. It would give you this value up here, which is y equals 5, or it would give you this down here, which is y equals around -2.5. So you can use the vertical line test to show you that, oh, this would give me 2 different outputs. This would be like pushing button number 1, right? We're at x equals 1, and getting 2 different, you wouldn't know which value you would get. So the vertical line test helps us test that. Let's just look real quick if we could do a couple more. What about something like this? Is that a function? Is that line a function right there? Well, let's test it with the vertical line test, because parts of it may look like it. Now right here at x equals 5, how many places is it touching the graph? Just 1 down there at y equals -3. right? It touches the graph right here. So at x equals 5, there's only one output. So that's good. That's a function. But what happens if we move it over? Oh, right here, look, at x equals 2, there are 3 different y values. It could be y equals 5, it could be y equals 1, or -3. So again, this would be like pushing the soda machine, the pop machine, Coke machine button number 2, and it could be any of 3. It would be a mystery what you would get out in the output. So that is how the vertical line test works, and it's really helpful. So let me see if we could do one more. We're going to send this to the back, and we're going to draw one more line, and you tell me if it's a function or not. Okay, we got another wavy line, but the question is this a function? Well, let's move our vertical line and test it. Okay, right here, you have to only hit in one spot, and we can move it the whole length of this function. Even though it goes up and down, it will still only map, each input will only map to one output. So this is a function. And notice, there might be the same y value repeated, right? So if you pushed the button at x equals -4, you would get y equals 1. Or if you push the button at x equals 2, you would also get y equals 1. That's like pushing 2 different buttons and getting the same Coke, for example. 2 different buttons map to the same thing, but this is still a function because you're always going to get the same thing for each x value. Each x value has one y value. All right, so let's wrap things up. Know this. Our little dinosaur friend wants us to know this stuff right here. What is the vertical line test? How can we use it? What does it mean to have a one-to-one function? And how do we test if it is a function or not? Know that, answer the Google form, and we'll see you soon.